Good afternoon, everyone. My name is Nabil Jawani, and today we are going to be talking about the Golden Gate Bridge and why it is the civil engineering landmark that it is today. The Golden Gate Bridge is located in San Francisco, and it connects the San Francisco Bay to the Marin County Bay. The landmark project was so revolutionary because the Golden Gate Bridge was a suspension span bridge, which means it was a suspension bridge, but it also had to span a great deal of length. And because of that, the engineers placed trusses underneath the bridge to help reinforce the bridge because it spanned such a great deal of length. When the bridge was opened in the 1930s, it was the tallest and longest suspension bridge. And because of that, it had to overcome a lot of engineering problems. Because it being so big and tall, the bridge had to have secure holdings all around it. And the base of the two towers also had many geotechnical problems, along with the suspension cables having to be super strong because of the really strong winds in California. The structure of the bridges consisted of two main towers, one on the Marin County side and one on the San Francisco side. And the towers are almost 227 meters in length. The bottom part of the tower is called the base traveler, and that is kept secure by two beams with diagonal fortification above each beam. And the upper sections of the tower is almost 152 meters in length, and those are kept sturdy with arches, and they are kept sturdy with four. The suspension bridge has a lot of pressure from the winds, and because of that, the engineers thought it was best to have like very long towers, and they kept them very secure and strong with the beams and the arches. The towers also had many very geotechnical problems because there are different layers in the bay, and what the engineers were looking for was the diabas or basalt layer, and that they found in the Marin County pier. So that pier was not that hard of a build. They just made a U-shaped excavation. But the San Francisco pier was very problematic because it did not have the diabas and basalt layer. It had the very soft serpentine rock layer. And that layer was also almost 50 meters in the water. So they had to build a fender ring first for the ocean currents that were coming in because they were very strong, because the San Francisco Bay is connected to the Pacific Ocean. So the ocean currents were very, very strong. So they had to build a fender ring so that the ocean currents wouldn't keep hitting the construction, and that allowed for calmer waters. And then they had to build the fender ring almost 35 meters in depth because the rock layer was so underneath the water. The cables used in the bridge were also very strong because of the winds coming in. They used number 6 galvanized bridge wires, and there were 61 cables, each with almost 452 wires. And when the head engineer Strauss was asking about how to keep the vortex of the wires when compressing them, the usual way is keeping the vortex in the middle of a hexagon. But in the Golden Gate Bridge, they found that if you place the vortex at the bottom of the hexagon, it decreases vertical displacement and creates a more ideal cross-section. So the cables were stronger and sturdier when building the Golden Gate Bridge. The cables were also kept in a cylindrical enclosure, and those helped the wires keep them safe from birds or anything like that, and kept them less pressure from the wind. But they also put packing material in the enclosure so the wires could still move. The Golden Gate Bridge was a great engineering feat because it overcame all these problems, and it was opened on May 27th, 1937. This is my references page, and as you can see, there are numbers. So if you go back, I have numbered my notes in the presentation. Thank you for watching. Have a nice day.